swinging bucket rotors. In the swinging bucket rotors, there is no certain angle for the placement of test tubes. It is going to have involved in large amount of samples to be involved in swinging bucket rotors. So there is no angle. It is generally a swinging. It is going to be swinging out in the horizontal position, which is perpendicular to the central axis. So it is perpendicular to the axis of the rotation, that is away from the central axis. The capacity is about 12 liters. The RPM is 4000 to 5200 RPM, which is very lesser than the fixed angle rotors and another rotor. And the vertical tube rotors. So this 4000 to 5200 RPM is very important, which means there is revolution to be occurs is 4000 to 5000 times per minute, which is very lesser than the both, which means it's going to have a decreased time. Within a few seconds it's going to undergoes the sedimentation. So when the acceleration is going to be occurs, the test tubes are going to orient as perpendicular to the axis of rotation, but it was going to be parallel to the centrifugal field. When the centrifugation stops, the rotor decelerates. The tube is going to fall at the original position along the axis. So during this period, that is going to be away from the central axis along the centrifugal field. During this period itself, there is different types of compounds is going to be sedimented off based on its density. So it is in general, it is going to be involved in density gradient centrifugation, which means different compounds, that is different components or cell components can be separated off in this swinging bucket swinging bucket rotors. It causes a cushion effect, so it lacks the wall effect, which causes a harsh to the components, which causes the mixing of components. A wall effect causes this, but it lacks the wall effect and causes smoothened effect, that is cushion effect. Then a major disadvantage in it is